Hello everyone, my name is Miguel A. Belenguer-Plomer. I am an Earth observation scientist at UMV, a private capital technology business group with an international presence, and now I'm going to present the long-term rangeland condition changes monitoring in Central Asia. This work was done within the Earth Observation for Sustainable Development Climate Resilience project of the European Space Agency, an initiative to support decision-making using Earth observation data. Most of the activities carried out in this project, such as wetland analysis, soil loss estimation, or the rangeland condition changes which is being presented, were in partnership with stakeholders, mainly international financial institutions. Specifically, the rangeland condition changes monitoring was requested by IFAD and FAO to assess the pasture land degradation during the last 2 decades in Kyrgyzstan and Tajikistan, countries where pasture activities are essential, making necessary to know the pasture status to improve livestock productivity. Regarding the data used, it was taken into account the available spectral bands taken by sensors on both Landsat 5 and 7 and also Landsat 8 for the period 2000-2004 and 2016-2020 respectively. Given the large area of the requested countries, the total size of these images was higher than 2,300 gigabytes, so cloud computing was used. In addition, it was also considered land cover maps, specifically the Chinese Lowland 30 based on Landsat data, also the SATM, Digital Elevation Model 30 meters, and last but not least, local information of rangelands at a regional and local scale was needed, which included seasonal grazing periods and altitudes, the distance between pastures and villages, and slope degree of the pastures. The first step of the data processing was to ensure the radiometric consistency between the different sensors since spectral bands didn't match exactly. Later, up to 9 different spectral indices were computed every 15 days within each grazing period for 2000-2004 and 2016-2020, using as input data the average images of the years taken into account in each period, being considered in the next steps only the maximum value of each index. Later, the IPCC guidelines for grassland degradation were considered to categorize the degradation according to each index into severely and moderately degraded, non-variation, and enhancement classes. Hence, up to 9 categorized maps were produced. These maps are combined in the next step. Before carrying out such a combination, only the indices with less than 75% of similarity with the rest of each season and region were considered. Besides, the importance of each index when assessing the pasture status was estimated using a random forest classifier and in situ observations. Following, a weighted sum model considering these importances was used to combine the rangeland status maps based on each selected index. Notice that as a result of such a combination, it was also computed the confidence level of the final result according to the difference between the individual indices and the final combination. The confidence was presented as low, moderate, and high using an empirical adjustment. In Tajikistan, the final results show a generalized degradation in all the seasons, being the highest in summer and the lowest in winter. In addition, no variation was found in most of the rangelands which didn't experience a degradation, being the enhancement insignificant. On the other hand, in Kyrgyzstan, we observe very similar results to Tajikistan, since there is also a generalized degradation in all the seasons, although here the highest degradation is in winter instead of summer and the lowest in spring. And also, the no variation category is the main class of the rangeland which didn't experience a degradation, having again the enhancement and insignificant presence. These maps have several applications, such as updating the national determined contributions of greenhouse gas emissions, identifying areas which deserve to be rehabilitated, and also developing pasture management plans. Finally, the main strength of the developed methodology is its functionality, since the results agree with the local knowledge of rural communities who are suffering the effects of rangeland degradation. In addition, the adaptability to specific grazing patterns and the low cost in comparison to field campaigns reinforce the potential of the presented approach. On the other hand, the main weaknesses are a strong dependency on precise local information as well as the necessity of measurements regarding rangeland conditions, and also the unbalanced availability of satellite data depending on the requested period. Thanks a lot for your attention.